Welcome everyone, and welcome to the first edition of the SPO Table Talk with domain experts. So this public format covers current Cardano stake pool and infrastructure topics, making them easy and understandable. I have to mention this. The table talks are recorded and will be available on the Cardano Community YouTube channel. If you're an SPO and you have a topic that you'd like to discuss in a future edition, please reach out to myself or Markus Gufler. These series are part of the Community Engagement Program. It's a quick side note about the moderation rules. All table talks, all sessions are topic driven and intended for sharing knowledge, not for self-promotion, not for project pitches, token sales, or of that sort. Having said that, we have a wonderful lineup of speakers for today's table talk, each bringing their own unique expertise to the conversation. First up, we have Andrew Westberg, community dev, SPO, and known for his wonderful contributions with the CNCLI. Andrew will be discussing SPO Leaderlogs before and after Chang. Next, Markus Gufler, also an SPO community dev, part of the Cardano Community Foundation team, and responsible for the Community Engagement Program. Markus will be speaking on the refined VRF tiebreaker rule, block diffusion pipelining, and the improved handling of blocks from the future. Then we'll have a brief video from the Cardano ambassador Lloyd Duhan discussing the evolving role of SPOs in this governance era. That's meant to set the stage for the final presentation from Martin Lang, who is also a Cardano ambassador, SPO and community dev, and will be presenting on stake pool operator scripts and security parameters that stake pool operators need to vote on, and more. But first up, Andrew, take it off.
Welcome everybody. Thank you for joining. We'll see how this new format goes. It's great to have kind of a more free-form format, I guess, for talking with the SPO community. I know we all talk to each other on Telegram, Discord, all these other channels, but hopefully this will be a fun format. I think what we want to do is I'll present briefly and then we'll kind of do question and answers. I'll be looking at the YouTube comments or the X comments and try to answer some of those if there's any questions. My section will be very brief, just because the topic I'm talking about today is not very big. So let's jump into it. What we're talking about today is leader logs before and after Chang. So in the previous era, we had the Babbage era. Leader logs, you can get them with CNCLI. You can also get your leader logs. This is when your pool is making blocks. You can get them with Cardano CLI now, or you can continue to use CNCLI, which is kind of the oldest tool that gave you your leader logs. But there's some changes that happened between Babbage and the Conway era that we're in now after the Chang hard fork. And it's actually a change for the better, I think. So what exactly changed is how the leader logs are calculated, and in particular, how the epoch nonce value is calculated. The epoch nonce is a big giant number. Usually it's printed as a hexadecimal number. And there's some math that goes into checking with that number, with your slot, and with your pool's VRF key. All of that combines to give the node an answer as to whether yes or no your pool can mint a block in any given slot throughout the whole epoch. and the calculation changed slightly as to how that nonce gets created. So there's two pieces of data primarily that go into the creation of the epoch nonce. The first is the first block of the previous epoch, the hash of that block. So we look at the block history, we go back one epoch, and then we look at that first block of the previous epoch, and that has a block hash. So all the data in the block, it runs through a hash, and we get a number there. And then the other piece of data comes later in that same previous epoch, and we look back so many blocks back at the what's called this stability window. The stability window is when we're pretty sure that nothing's going to change and things are kind of set. So the stability window in this new Conway era has changed. It's grown a little bit bigger. The calculation was 3 times K over F in the Babbage era, and that changed. The cryptographers decided that it was okay to change, safe to change, to 4K over F. So that stability window represented 1.5 days before the start of the epoch, which means 1.5 days before the start of the epoch, you could know what blocks you were going to make. Now that stability window has increased, and it's now 4K over F, so we get 2 days before epoch you can actually calculate your leader logs. So that's a good thing. Now, if you're using CNCLI to calculate your leader logs, there's a parameter that you need to change on the command line. Before you typed the parameter -- consensus Praus, Praos, and now you need to type in C Praus for Conway or Chang Praus. And that's to do that change inside the code to say now we're using 4K over F to calculate that epoch nonce slightly differently. Yeah, so happy getting your leader logs a little bit earlier now that we're in the Conway era. So if you have any questions about that, feel free to just chime in on the socials, and we should see them here. Otherwise, we can close my section and move on to the next presenter. Looks like not a lot of questions, so I suggest we move on. Yes.
Andrew, I do have a question here.
Mm-hmm.
So if someone that uses the CNCLI tool,
mm-hmm.
where can someone, let's say, where can they find all of this information?
Yeah, so all of the information is available in the GitHub repository, and it's under the Cardano Community group. So github.com/Cardano-community/CNCLI if you're using it directly. It's also built into the CN tools if you use that. And then there's an installation guide. There's also a usage guide that goes into the explanation of each command. And there's a lot of different things CNCLI does other than leader logs, but that's the main thing we're talking about today that has changed. And that's important also if you're one of those people that sends your leader logs to Pool Tool, because if you don't do this new switch, you're going to be sending a completely wrong set of blocks to Pool Tool, and then you're going to look really bad on their website. So make sure you get this up to date before you send your blocks to Pool Tool. Which version of CNCLI is for Chang? The latest version. I believe it is 6.3.0 is Chang supported. You mentioned cryptographers thought it was safe to do so. Why was the change made? That's a great question. I don't know. Possibly that's something Sam could weigh in.
Yeah, can you hear me?
Yes.
Yeah, so the general thing is the governance structure of how things are done in Conway are calculated slightly different with snapshots. Whereas prior, we had to have two security windows basically before we could make it, which gets you 6K/F through. Um, and now we can finalize things a little bit earlier. I believe what they did, you said it's 4K/F now. I believe
Right.
what they did was take it so we only need one security window, but increase the
Mm,
security window by an extra K/F.
that makes
Esgen, do you
sense.
have anything to add on that?
Yeah, so that particular change is actually motivated by Genesis. So Ouroboros Genesis, a change that will roll out in an upcoming node release. It is important for certain security properties of Genesis that the IO researchers have advised us on. And it was actually always the idea to set this value, to set the non-stabilization window that Andrew explained to this value 4K/F. But due to an oversight, it was set to 3K/F. That's not a problem without Genesis. But with Genesis coming up, we want to set it to the correctly larger value of 4K/F.
Excellent. Yeah, one thing I didn't quite communicate earlier was the two values. The first value is that block hash, first block of the previous epoch. The second is actually not a block hash, it's a rolling nonce. So every block gets rehashed and added to this rolling nonce value. And then you look back at that security window or stabilization window, and then you go grab the rolling nonce before that that slot. And then those two pieces come together to give you the epoch nonce to calculate the leader logs. So okay. I'm not seeing any other questions. Yeah, thank you, Sam and Alexander, for weighing in on that as to why the change was made. That was great information. I didn't know it. Excellent to have you guys here for those type of questions.
Thank you. Thank you as well. Up next, we have Marcus. Marcus, you're up.
Hello, can you hear me? Okay, good. So I have prepared some slides in order to keep it as short as possible. What I wanted to bring to your attention is all the non-governance changes that come with Chang hard fork. So, of course, all the focus is on governance, SIP 6094, DREPs, and so on. But this node release, 1.5 years after the Valentine hard fork, also brings a couple of things. The first one was just explained by Andrew with the non-stabilization window. We also have a new tiebreaker for hate battles. We have an improved block diffusion pipelining, and we have a fix for the handling or an improved handling for blocks from the future. Let me explain in very short what this means. The refined VRF tiebreaker. So if you see here how the blocks are scheduled and then also usually produced, it can happen that these two blocks here are not built one after each other, but it is a hate battle. What you hear and what you usually know as a hate battle, and no SPO wants to have that. In this case, it is a hate battle with, can also be a hate battle with more distance. And what we have now is that so far what we had is that whatever hate battle, so whatever slot distance the hate battle was, just the solution was the lower VRF hash, the block VRF hash wins. And it was a 50-50 chance that one of the two involved in the hate battle wins, which causes sometimes that, let's call it the wrong one, so the one who propagated his block way too late, won the hate battle instead of the honest and correct block producer. What we now have is exact the same as we had so far for hate battles within the first 5 slots, but we have a new tiebreaker rule if this hate battle is the slot distance is more than 5 slots. And what the change is that instead of going for the lower VRF hash, the node retains his fork, so the block that he has seen first. And he keeps it until another longest change potentially wins. So this means it is not a solution by lower VRF hash and I go back to I switch to that fork, but I keep what I have seen first. And this means that the block producer who propagated in time and very well has a higher chance that the next block producer adds the block on his one, and so it becomes the longer chain and he's going to win. What we expect is that it becomes a better outcome for honest ones and a very good motivation for time off, operators who don't care about the correct system time or the resources of the relay nodes that they actually care about, because we expect that they will lose a majority of these hate battles. We already had the first case after the Chang hard fork, so I have a monitoring on this, and we had the first case. The problem is that PoolTool has not seen it, so we don't know if it actually was then a different outcome now based on what it was before, so the lower VRF hash. But actually we had one such case, and this is also the next chart here. This is a historic view on the hate battles. You see here, it goes from basically December last year and covers the whole 2024. And we had phases here at the end of last year, if you remember, and then also in around March of this year, where some SPOs was a little bit understaffed or with the wrong system time. And so we had 20 up to 40 hate battles caused by late propagation per epoch. And the time ranges here, you see they start from 5 slots and more. So these are only hate battles with more than 5 seconds distance, what I have counted here. And you see in this phase, it was even hate battles up to 100 slots or seconds. And here even up to 150 slots, almost 3 minutes. And the mean value, you see it here. So right now we have close to no such hate battles per epoch. And actually, and this is a little bit sad for the engineers like Alexander here who implemented this, is that it is one more such solution and code in the node that gives a strong motivation that it is never executed. So like if it works well, then everyone cares about the system time and proper block propagation, and then it is not a nothing burger basically. Ideally means, and we already have a lot of such mechanisms implemented, so The next topic is block diffusion pipelining, and the thing here is what I wanted to show, a thing from the past. It was introduced already 2 years ago, and what you see here is a difference, what it caused it, what it brought by introducing it. So first there was an epoch, and these orange bars, this was all blocks lost by hate battles. And after it was introduced in the second graph on the lower graph, you see how it improved, and we had less these orange hate battles. So the solution works. It forwards the blocks before the local validation, so it is saving time and sends it forward. And the original criterion, can I do this pipelining as a node, is tied to the tiebreaker rules. And this made it difficult to improve the tiebreaker rules, like what I just broke before. This new VRF, this new hate battle solution required a change in these tiebreaker rules, and it has a lot of dependency then. So it made things difficult. And now here we have a new criterion that is completely independent of the tiebreaker rules. It is simpler and more efficient. It looks basically for each blockade, a node will pipeline only one block. That's a very simple thing, very efficient, and provided by the researchers at least the same secure, if not even better. Optimizing network performance while maintaining security. And as a best outcome, more flexible as it is not tied to the tiebreakers anymore. Last thing, blocks from the future. So usually this is how it looks like when everything goes well. So you have here the slots, and you have a scheduled block, a produced block, and this is how different nodes around the globe see it announced, then requested, downloaded, and adopted. These very small colors here. The blue bar here is the time it takes for the node to validate the transactions and adopt it locally. So this here is how it not should be. And this was a bug identified around a year ago. What you see here is when you look at this yellow dotted line is that all the nodes who learned about this block from the future a little bit too early ended up in a stuck situation. So the local adoption took not forever, but until the next block was announced on chain. And this is not what we wanted because it caused a hate battle for the next block producer. If the next block producer was feeded or did not receive the block because this adoption here took too long. And the new solution implemented now solves this. So these blue bars don't happen anymore. So we should also not see this kind of hate battles anymore. A very last thing here is, this is a graphical overview on the history. It goes back to 2022, and it shows the different node versions colored. So from 1.35 to 3, and up to now 9.00, 9.1, 9.11. And what you see here is that this purple 9 versions, it was required to reach this 70–80% to trigger the hard fork. And then here, after the hard fork, what you see is that only purple nodes are on tip and running the mainnet, and all other nodes that was not replaced in time basically fall off and are not active or not participating in the mainnet anymore. So an interesting view, and here you already see jumping in the 9.11 hotfix version, and we will draw this colored chart here in the future also for the next year altogether. What we also did is, what you see here is the last 2 months, so from mid of July. In mid of July, 100% of blocks was produced by version 8 nodes. And then the first 9.0 node version came in, and some operators started migrating. We had then a 9.1, so they replaced it. And then we had to replace, all the SPOs had to replace or upgrade their nodes and start producing Chang or Conway-ready blocks. So here we reached the threshold already in mid of August, and then it took a little bit longer for the upper layers in our ecosystem, so applications, DEXs, and so on. And we ended up in the hard fork, and after the hard fork, only 9 dot something, so version 9 blocks was on chain. That was it from my part. Thank you very much.
Excellent, Markus. Again, if you're just joining in this session, the first SPO Table Talk, and you have questions for the domain experts, feel free to submit your questions via the chat. We're eager, we're eager to connect with you, engage with you, and answer basically any questions that you may have. Again, thank you, Markus. Just one question from my side. Hype battles. With this new, let's say, enhancement, it doesn't mean that there will never be hype battles anymore, right?
No. There's
Okay.
let's say, there is one new strong motivation now to care about the proper nodes in order to avoid such kind of hate battles, because now your probability to lose the hate battle and so also lose reward for you and your delegators is not a 50-50 anymore. It is on a clear disadvantage for you. There are still some reasons for hate battles, there are different reasons for hate battles, and there can also be inverse reasons. So like the first block producer actually produced and propagated right in time, but if a short afterwards producer is low on resources and he has not problems to propagate his block, but even to receive the preceding block, then he builds on the second previous or the other block, and this also causes a hate battle. So it can also be that the second producer is the let's say the wrongdoer here, and this potentially comes, or this became way more a topic with the stake-weighted peering selection. So in P2P, dynamic P2P, and if a stake pool has relatively high stake and low relay resources, this results in P2P now with a lot of incoming connections. A lot of incoming connections mean a lot of resources, so a lot of demand to talk to all these nodes. The more pools, the more nodes we have, the more connections, the more interactions, the more efforts is there to keep the network all synchronized. And a large stake pool clearly has to look at his relays and see that he is able to respond all the incoming and outgoing traffic in order to avoid hate battles. If the hate battle becomes too long, larger than 5 slots, there is a probability that even if he is the late one wrongdoing, the propagation for him being on low resources is worse than the other one, so he has less chances to become the longest chain afterwards. So SPOs need to look at this and understand it. But the good thing is, SPOs who don't care will lose, and SPOs who care about their resources and the infrastructure have a benefit, a relative benefit on the other side.
Yeah, thanks for clarifying that. Absolutely. Just one more question from my end. Is there anything being developed on your end to help SPOs manage performance or in any way, shape, or form?
Yep. Good you ask, by the way. So this is something where I had announced it already last year. There was some delays, but now I'm actively working on that monitoring part, where the idea is to actually collect data from every SPO who want to participate, and then all what you have seen here in these charts is based on this data that we already collect. The next step is to invite more SPOs to participate in this, and the very important step is to also give the participating SPOs insights and direct access to this data, so they can form their own opinion, also do their own charting, research, analysis. And it is not so much, I personally don't see it even so much important for their own node operations. Of course it helps, but what we have now is convey and governance. And in governance there will be questions, or there will be voting proposals to change some parameter. And SPOs also participate in voting, or they express their opinions, and they are the technical experts of the network. So they should be able to see what it means in the network, where we have some room, where are the bottlenecks, how it works, in which situations we had some problems, where we can improve. And a parameter change then is something that can be combined with measured data, and then it allows to form some fact-based opinion, and also some answering to requests or to proposals for a change. So my hope is that we can jump into this already at the end of this year, and then for the next year, a lot of things, very interesting things to come on this.
Yeah, wow, amazing. Markus, there's also a question coming in from New Lady of the Lake Pool. Will the VRF tiebreaker be further looked into? Because height battles can still be caused when someone has very bad propagation. Somehow, the solution implemented is only part of what was proposed first. Basically, the more relays we have, which are also quick to propagate, the more likely to win a height battle. Is that correct?
Alex, feel free to jump in, but my answer in very short will be that the thing sounds, in the first moment, may sound a little bit simpler than they actually are. The Ouroboros protocol has a lot of very genius things in, but also a lot of dependencies. So it is not that easy to just change some, let's say, very concrete hate battle problem with some potential solution without looking at all the potential conflicts or effects that we don't want to have.
Okay.
Yeah, I can add on that a bit. So I think this question was posed on X, and yeah, there is also a link to a GitHub issue that is the place where this was originally discussed. And indeed, there's a possible further refinement of the tie-breaking rule that we just covered. So Markus just presented the updated tie-breaking rule that is now used starting in Conway. And there are possibly further changes we could make that would give us even more advantages in certain situations where a pool that diffused their block in a weird way or used insufficient resources to run their pool causes them to sometimes win a height battle even though they certainly do not really deserve it. And the answer to that is that, just as Markus just said, the implications there are usually a bit subtle. We are basically talking about a incentivization problem here, like a bit of game theory or mechanism design. While we don't maybe... so making a final decision on these things always requires a lot of thought, that we are not suddenly incentivizing something weird. But indeed, there is a relatively plausible path for a further improvement on the tiebreaker that we might come to, but we haven't yet fully analyzed that. So that's something that will need to be discussed, happily also with the community in that GitHub issue, but also internally, depending on other priorities.
Yeah. So in other words, let's say it's still in progress, basically. Something that still can be improved.
Yeah.
Further upon.
And I welcome everyone to go to that GitHub issue. Maybe I'm not sure if we can post a link here, but it's like issue 2913 in the Ouroboros network repository. That issue also has a lot of very concrete examples if you want to take a look at the more subtle consequences of the tiebreaker rule.
Okay, excellent.
To add to that, it's also not just the prioritization of issues to work on, but it's also making sure that we meet the security guarantees by Ouroboros. So just because something is popular and we want to put it toward the top of the priority list doesn't mean it's necessarily plausible. It has to sometimes go back to the researchers and make sure it doesn't violate the constraints that give us the security we need for the network.
Yeah, so it's not as easy as it sounds, basically, because of the many dependencies as well. Marcus, you just addressed that there, right? Like in the current era that we're in of governance, how important that will be to have factual data, in order to guide us through the process. And I think at some point it will be relevant to really have some sort of information or research-based or analytic data that will help us kind of, draw conclusions, especially for those proposing, let's say, funding for improvements. So thanks for that. Any more questions? No? Okay. I think we're good. So right now we have a very brief video from Lloyd Duhan about the, let's say, the evolving role of stateful operators, specifically in the governance era. And the reason why we're showing this short clip, that is to an introduction of the final presentation from Martin Lang, where he really goes into, let's say, that specific part of the role of the SPOs in the era of governance. So yeah, sure. We can play the clip.
GM Cardano, I'm Lloyd Duhan, and this is Governance Matters. Today, we're diving into the crucial role that stake pool operators, or SPOs, will play in Voltaire governance. Many of you know SPOs as the backbone of Cardano's network, responsible for block production and maintenance. But in the Voltaire era, their role expands significantly into the realm of governance. Before we dive into their new governance roles, let's quickly recap the traditional duties of stake pool operators. SPOs are the workhorses of the Cardano network. Their primary responsibility is to maintain and run the nodes that process transactions and produce new blocks. This involves setting up and managing the hardware and software required to run these nodes, ensuring high uptime and reliability. SPOs also play a crucial role in network decentralization by offering a way for ADA holders to delegate their stake and participate in the network's consensus mechanism. They're responsible for configuring their pools, setting fees, and maintaining their performance to attract delegators. In essence, SPOs have been the technical backbone of Cardano, ensuring the network's smooth operation and security. Now, let's break down the key areas where SPOs will have a voice in the new Voltaire era. First, let's look at motions of no confidence. SPOs will have the power to vote on motions of no confidence for the Constitutional Committee. This means that they're holding the other branches of the government accountable, and it ensures that the network's best interests are always at the forefront. Next, SPOs will participate in electing Constitutional Committee members and changing the parameters for the Constitutional Committee. This committee plays a vital role in interpreting and applying Cardano's Constitution, so SPO input here is crucial. Third, SPOs are responsible for voting to initiate hard forks. When major changes to the Cardano protocol are proposed, SPOs are going to have a say in initiating the hard forks. This ensures that those running the network have a voice in its evolution. Finally, SPOs will be responsible to vote on security-related protocol parameters. Their hands-on experience with the network makes their insight invaluable in these technical decisions. This expanded role transforms SPOs from operators of network infrastructure to active participants in Cardano's governance. It's a testament to the decentralized nature of Cardano, where those who maintain the network also have a say in its future. Remember, good governance is about balancing different stakeholders' interests. By including SPOs in these crucial decisions, Cardano is ensuring that the technical realities of running the network are always considered in governance decisions. This episode of Governance Matters was made possible by a grant from Intersect. GM Cardano is a production of Melody Studios. Support good governance on Cardano by sharing this video with your friends. Thank you for watching, and we'll see you next time.
Yeah, I just love that video. Gives so many information. Martin, you're up next.
Hi, hello. Can you hear me?
Yes, we can.
Okay, let me share my screen.
If you're just joining, this is the first edition of the SPO Table Talk, a open public format where we speak to domain experts. It's topic driven and meant basically to empower other SPOs within our ecosystem and aspiring SPOs who'd like to join this ecosystem. Today, we have experts, Markus Gufler, Martin Lang, we have Andrew Westberg, we have Alexander, and we also have Samuel. Thank you all for joining. And of course, we're up next to the final segment. That is Martin. Martin, continue, please.
Okay, so I think I can skip some things because of the awesome video introduction from Lloyd. Here's the webpage from Essential Cardano, which again shows all the different actions, governance actions that we now have in Conway era and where SPOs can vote. I just noticed right now that for the info action, SPOs are grayed out. So again, to just repeat it, SPOs can vote on the motion of no confidence. That's one of the most hardcore actions we have, because it's basically saying we are not confident in this constitutional committee and we want them no longer to work. And one thing to mention is if such a proposal is on the chain and there are other proposals, and this proposal will get ratified and enacted, it will simply flush out all other actions, and this will be in place, and we will switch to the state of no confidence. Yeah, the next thing is we have a say as SPOs who is on the Constitutional Committee. There might be some actions that will add members, that remove members, or there will also be actions that simply change the quorum. So how many members you need to vote yes, that an action get enacted by the Constitutional Committee. Then we have the info action. As I mentioned, this is wrong here. We have already one info action on mainnet, as many of you know. So, and SPOs already voted on this. We can vote on this. A really important one is the hard fork initiation. Up until now, the founding entities were responsible to initiate the hard fork on the chain, especially our special guest Samuel here. But from now on, it's our responsibility. So we saw this in the last weeks with the apps getting ready, and we really have to organize ourselves in the future, come together, do our job, and yeah, you have to actively vote on such an hard fork initiation and saying as an SPO, yes, I have upgraded my node, yes, I'm ready, and yes, I want the network to fork. And an important thing to remember here is once we get the critical threshold from the DREPs, from the Constitutional Committee, and from the SPOs, the network will fork. There's no going back, no rollback, nothing. So this will be a really important thing to look at, especially for the next hard fork. But as this hard fork showed, SPOs are really spot on. Thank you again for this. Yeah. The engagement was really high, and we reached the threshold for SPOs really quickly. So here are protocol parameters, and SPOs are grayed out. And if you just look at this chart, you might miss something. So let's switch over to the actual SIP 6094. Here you have all the different actions again listed on a table. And if you scroll further down, we will see another section, and these are the security-related protocol parameters. We as SPOs are responsible to run the network, to maintain our nodes, and so we are really also responsible for the security of the network. So out of all the different areas from the parameters, there were some picks that are really important for the network. Yeah, like the block size, execution units, transaction fees, and so on. And the purpose is to really make sure that the network doesn't go nuts and slide into a dangerous state. There's also one here. This is the governance action deposit. We have a say on that's basically because we don't want the blockchain to be spammed with not really serious action proposals, because all we should take action and vote on such proposals. So if this would get too low, people might start to spam the network. So if anyone is saying pools cannot vote on protocol parameters, it's actually not true. There are hand-picked, really important ones that SPOs must vote to get ratified and enacted in the action. So let's jump into some live action here. And I want to do this with the stake pool operator scripts. Many are familiar of. We can maybe share the link later on the GitHub, from the GitHub repository. And if you're not familiar with them, the stake pool operator scripts are just a collection of bash scripts for your Linux environment on the CLI that are doing more or less nothing else than wrapping Cardano CLI, Cardano node, Cardano signer commands into some handy little scripts, and not in a large one that no one really can read anymore, but in just little tiny chunks. So if you want to become a developer, or you want to make a project on Cardano and you want to use the Linux CLI, and you're not familiar with Cardano so far, that may be a good starting point to understand how to use the CLI. And the scripts can also be run automated. So if you, we have seen people doing NFT sales with them and so on. And let's jump right into some live actions. Let's see if this works. I will do this on SunShineNet. I know one of you is now excited. SPOs, let's talk about DREPs. So I know that many of you want to become a DREP, and I really can encourage everyone to become a DREP, because think about it, you already have a bunch of delegators that are delegating to your pool, and you may give them the opportunity to also say, yeah, we trust you with your governance decisions. They may not be the experts in some fields, and you may want to give them the opportunity to also delegate to you. And I want to say, because I've heard this very often nowadays, no, I don't want to be registered as a DREP because I'm no expert. You don't have to be an expert. I'm not an expert in everything. For example, for all the NFT stuff, I'm not an NFT guy. But I decided to become a DREP because beside all the SPO votes, I also wanted to have a say in proposals like treasury withdrawals, have a look at them and other stuff. And if a proposal comes up that I don't understand or I'm not an expert, I can still vote abstain. So don't be afraid to become a DREP. And let's jump right into this. And when you download the SPO scripts, you will just get a bunch of scripts that are separated in different sections. Each section has a different starting number, and all the new governance stuff starting with 2. And let's make a really quick live demo, and let's start. If you want to generate a DREP keys, you have the script 21.8. And when you look at the parameters that you can give them, it's just a name and then the type of key that you want to produce. A CLI key is just a regular CLI key. Encryption is standing for encryption. It's a CLI key that is encrypted with your own passphrase. You can generate DREPs also on hardware wallets. You can do it on Ledger hardware wallets and also on Keystone. You cannot do this on Trezor wallets. You can only vote delegate on Trezor wallets. And you can generate DREP keys with mnemonics, and this is what we were gonna do now for this little demo. Let's call this demo DREP, and we wanna do this with mnemonics. And what this is going to do, it derives keys from this special path. I know this is a little bit nerdy, but this is the official path to derive DREP keys. And this generated you your familiar public key and your secret key, but also mnemonics. I have to say, we are now in live mode here. You should do this in offline mode, of course, to have more security. But what this allows you to do, you can use your DREP keys on the CLI, and later on, if you decide, okay, I want to do some things online, you can import them into Lace, into Eternal, into any light wallet to use it later on. So what's the difference between a private DREP and a public DREP? Basically nothing. The only difference is that public DREPs will share metadata so that people know who they are. There's no other technical difference between them. And let's register a public DREP. So just to confirm that this DREP is not on the chain, we have this DREP ID you can see here. And we can quickly check on this. And you can see that the DREP is not registered on chain yet. So if we want to register them, we can use the script 21b. And what does it take as input parameters? Just the name again, and then the payment address of your CLI wallet. Here are some options, and we are going to use the first one because we want to make this a public DREP. As stake pool operators, you are very familiar with off-chain metadata because your stake pool metadata is also off-chain, and you'll just simply link this offline metadata on your web server to your pool registration, and there's nothing else here. It's the same with a DREP. And for that, I will just quickly show you a SIP 119 example here. So basically very similar to SPO metadata. You have your header up here and then have your body with your title, what you're doing. You can insert a picture here, you can insert links and so on. Let's register a DREP. Again, we use 21b for our demo DREP. We are using our CLI wallet funds, and I have already uploaded this file to a test server. And let's see what this does. Let's scroll up a bit. So here you can see it goes out to the web server. It downloads it, it generates the correct hash. It checks the chain again if this DREP is already registered. No, it's not registered, we just created it. And we need to pay a deposit fee of currently 500 ADA for this. Here is the wallet we are using, currently 150k ADA on it with the 500 ADA on this. We will say yes. So, and now we have to wait for a Sancho node, for a Sancho block. Maybe there are some questions in the meantime, or maybe this is getting quick enough. So let's see.
Just unmuted myself. This is actually a great example, of, let's say, the power of the stake pool operator scripts that basically out of the box, that really helps you basically manage or not only create, your DREP credentials, but I think there's also more to this, right? Martin, just a question. What was the purpose, or what drew you to really create the stake pool operator scripts? What was your thought behind that?
Yeah, so the main purpose started with before the Shelley area. We had a friends and family network where we were a bunch of selected peoples trying out all the stuff that later came to the ITN test network. And for these, we had to really start from scratch, you know, doing all kind of debugging and tests on the CLI, and yeah, I started to write little scripts to make this a bit easier, and this was the birth of the SPO-Scripts. They involved a lot over the years. If you look at all the scripts, you can make wallets. You can use your hardware wallet. You can generate NFTs. So, and I'm always trying to bring all the latest. What the guys from IO and Sam and all these other awesome guys are creating, and bring it to the CLI and to make it a bit easier than just running normal CLIs.
I'm curious because now, of course, you know, we're in the Conway era. We've evolved quite a bit over, let's say, the past 4 years. How many SPOs, just in total, is that known to you that uses the stable operator scripts?
No, I don't really have a number, but I had really nice discussions at the summit in Dubai last year, because a lot of SPOs from Japan and the Asia region came up to me and thanked me for making this collection, and that was one that really surprised me. I didn't know about it, that this was such a popular thing over there, and thank you again for the SPO community over there.
Cool. One last question there, indeed, from Victor, and I know we're very tight on our time, but are there any UI tools available already, you know, to construct the metadata? Do you know that? Or maybe one of the other gentlemen on the panel?
I think the 1619.4.io page from Lido Nation, I think if you create an account in there, they can create the metadata. Otherwise,
okay, so Victor,
not aware of one.
Not fully aware, but you can always check out the 1694.io website from Lido Nation. Perhaps there is some information there. All right, then we have here Jamie Andres. I guess this is not really a question, but we are now a Cardano D-Rep. We're doing the respective announcement. Start. Okay, good for you. And this is exactly what Martin's point, trying to encourage the stake operators as well to sign up as D-Reps, you know, and work together with your delegators. So good for you. Markus, how are we doing with the registration?
So let's see. We had a lot of blocks now in the meantime, and you can see that the D-Rep is fully registered on the chain. And the scripts present here two different D-Rep IDs. We have the current one, which is coming from COP 105. This is this here. But there may be an update or a shift to SIP 129 in the future. This is just for visualization, and I know that tools like the scripts, Koios and Eternal Wallet already accept both D-Rep IDs. And for those of you that already very familiar with all these processes, and you are creating a script so that you can be multiple people, for example, to become a D-Rep, or you are creating a Bluetooth script that is a D-Rep, just be aware that there is also another prefix that is not D-Rep but D-Rep_script. That makes it easier for other tooling on the chain really to separate, okay, this is now a script. Let me quickly change over to SanchoNet Gov tool, and let's see, let's copy the D-Rep ID, and let's see if this is showing up here, and it is. And let's view the details, and you can see it already picked up the metadata in here, so that worked pretty fine. I know we are running out of time. What I quickly want to show you is there are a few changes now with Chang, and are coming with Chang +1 hard fork. One is, and Sam and I discussed this shortly today, please start to sign your stake address registrations now also with your stake key. This will become important because now also the stake address deposit fee can change. So this is a requirement. But, and this was the point where I started with DREPs, one important point is, and I know that many don't have this on the radar yet, with Chang +1, you can withdraw rewards if your stake account is not vote delegated to a DREP or a state of always abstain or always no confidence. So
just to be clear, that's you can't.
You can't. So
Cannot, okay.
This was baked into the protocol basically to encourage people to do the vote delegation, either becomes a self-registrant or to delegate to DREPs. And I know that many SPOs are having a separate reward account, and I have created one here that's simply called rewards, and it is delegated to my testnet pool, but you can also see that the voting power of this account is not delegated to any DREP. So if I would stay this here, let this here, I would have a hard time after the Chang +1 hard fork to withdraw my pool rewards. So let me just quickly show you how easy it is with the scripts to delegate now to this new DREP that we created ourselves. For this we have the script 22a. This is a vote delegation, and all you have to input is again a name or a DREP hex or a DREP back string, so you can pick one from the public community, you can pick yourself, and your stake address. And when we do so, we will do this with our reward wallet. It creates a vote delegation certificate, and all you have to do is to register this vote delegation on the chain. This is for the rewards account, and we will pay with our little funds wallet here. And let's see what this did. It just writes out again the DREP that you will be delegating to, and we just had a new block. And if we are doing the query again for the rewards account, you can now see that the voting power is delegated to a DREP. So that would be basically all you have to do to get your rewards again after the Chang +1 hard fork. I will stop my section here. I could talk for hours, and yeah, we'll hand it back to you, and yeah, let's see if there are some questions.
Excellent, excellent. Okay, so the live stream on X, thank you, by the way, Martin. This was very, very insightful, and I think it also displays the power of the stateful operator scripts, right? And also why a lot of people are using them. So thanks to you, of course, for making this possible to many of the hundreds of SPOs that are making use and helping to secure the network, of course. Having said that, I know we're out of time, and we really wanted to try to keep this at an hour, if possible, even under 1 hour. But I do want to thank everyone for joining today. Again, this is the first edition. This was the first edition of the SPO Table Talk. Yes, there will be many others, on demand. And if you are an SPO in the Cardano ecosystem and you have a topic that you'd like to address in a future episode, reach out to myself, Markus Gufler, or someone from the Cardano community team, and we will work together with you to make this possible. Thank you all. I do want to thank all guests who have joined today and participated, all who've asked questions. It's just great to see you all engaging with each other. That is also part of the community engagement program that we're executing here. And thank you all. Thank you, Samuel Leathers. Thank you, Andrew Westberg. Thank you, Alexander Egan. Thank you, Martin Lang and Markus Gufler. Thank you all for joining today. And until next time, let's continue to build together.